Hello and welcome to my review of the 2024 AMC10B. As I have stated on the thumbnail, this is a bit of an unusual paper in the sense that the last 5 questions are not very hard. Now my intention, as per the AMC10A video, is that I'm going to try to run through all the questions in 75 minutes. That would be the pace for someone who is intending to finish the paper in the time allocated. Now, before we get started, therefore, I just want to mention a couple of important reminders. Now, the first thing is that the questions are not in the same order for the paper version, the online version, and in different time zones. That's an anti-cheating measure. And therefore, I've attached a copy of the problem set that I have, meaning these orders of questions and options in the description below. So you can refer to that just in case yours is in a different order. What it also means is that when you look at the questions, the AMCs are already not perfectly in order of difficulty, but they do scramble the questions even more just to prevent cheating. And that further makes it such that the order of difficulty is not strictly increasing. You would expect question 1 to be not very hard, but you should not assume that the last 5 are impossibly hard. The next thing is just that in reference to that, your targets will be a bit different. The cutoffs for this AMC10B for AIME qualification was 105, for a distinction was 114, and for a distinguished honor roll, it was 138. So these were the cutoffs last year. As you can tell, that would mean that your targets will be very different. So therefore, as I mentioned in the other video as well, you would like to finish the first 10 questions in about 15 minutes if you're aiming to get a DHR or finish the paper. But if you're aiming for AIME qualification, 15 questions are enough, which technically means that if you take 45 minutes to do 10 questions, you are probably still okay, right? Which is totally different from 15 minutes to do 10 questions. And this is why for something like the AMC, we can take it every year and the challenge is a bit different, right? You are going to actually not find that the questions are getting harder. It is just that you will need to do them at a much quicker pace if your target increases year by year. Okay, so without further ado, let's get started with the questions. I've not really looked at these since last year, and therefore this is going to be a semi-live solve, meaning I've solved it before. I have a list of answers to make sure I don't say anything silly, but we are going to go through the same thought process as in a competition. Okay, question 1. In a long line of people arranged left to right, the 1013th person from the left is also the 1010th person from the right. How many people are in the line? This sounds like the kind of question that is easy as long as you don't get off by 1. Right, so you've got this guy here, this person. He's the 1013rd person from the left, so there are 1012 people here. And 1010 from the right, so there are 1009 people on the right. So your answer is just 1012 plus 1009 plus 1, which is 2022. When you see all the options like that, it's a reminder that don't make the mistake of being off by 1, since all the options are basically there to trap you in case you accidentally forgot to subtract 1 or forgot to add 1 or something like that. Question 2. What is 10 factorial minus 7 factorial times 6 factorial? First thing is that you should suspect they're not asking you to really multiply everything. And so when I see this, I think I'm going to shortcut it by noticing that I can factor out 7 factorial first. And 10 factorial will have another 8 times 9 times 10. And then this has 6 factorial. Now 8 times 9 times 10 is of course 720. 6 factorial is small enough that we can either calculate or we remember it is 720, and therefore the answer is just 0. These are the kinds of questions where of course you are just talking about the difference between solving it in 20 seconds and solving it in, let's say, 3 to 5 minutes. You'll solve it anyway. If you are the one who is going for the DHR or distinction, you want to go a bit faster. If you're aiming to just qualify for the AIME, it's okay to take 3 minutes to, just do it in the traditional way. Question 3, yet another counting question where it looks like the risk is off by 1. There is a small little thing of estimating 7 pi. Now, if you took pi is about 22/7, then that will be quite disconcerting because we are not sure whether it is a bit more or a bit less than 22/7. You would like to get a slightly better estimate, and the slightly better estimate would be that your pi, well, as many digits as you need, it is less than the 22/7, confirming that this thing is 21 point something still. So if this is 21 point something, the absolute value of 2x is less than 21 point something, means x can go from -10 all the way to +10. And so your answer is 21, not forgetting that there is a 0 in between. The good news is that the question choices are quite compassionate. If you had estimated wrongly and you thought this is 22, you will end up with your answer as 23 different values of x, and then you know that's wrong. So technically speaking, this estimate is something that if you did wrongly, the answer options will kind of tell you that you've done it wrongly. Okay, question 4. You have got 5 bins, A, B, C, D, E. You put 1 ball into A, 2 balls into B, 3 balls into C, 4 balls into D, and so on. And in which bin is ball 2024 deposited? So we know that when we sum up from 1 to n, there's the formula. Basically, 1 ball, then 2 balls, then 3 balls, then 4 balls. I want to know which step 2024 was in. So we just need to estimate if n times n plus 1 over 2 is around 2024, that means n times n plus 1 is around 4,000 and something. So I will try n to be somewhere around 60 something. Okay, so if you try n equals to, let's say, 62. You know what? Actually, let's just use a simple calculation of 60. I think that's easy to calculate. Because if this is 60, then I can just add 61, 62, 63, and then 64, which means that it is in the 64th step that this ball 2024 is deposited. That means that if it is ABCDE, ABCDE looping around, then clearly that will be a remainder of 4 when divided by 5, so it will be bin D. Okay, question 5. What is the remainder when this sum of 3 powers of 7 is divided by 19? The typical way in which we will do this is just by finding pattern when powers of 7 are divided by 19. Right? So powers of 7 mod 19, 7 itself, then 7 squared is 49, the remainder is 11. Then after that I can multiply by 7 again, 77, divided by 19, the remainder is 1, and so it just loops around 7, 11, 1. That's very convenient because I don't even need to know which is which. I just take 7 plus 11 plus 1, which is, oh, that's itself 19, meaning that the remainders sum to 19, so actually the overall remainder is 0. I would like to say at this point that actually the front part of this AMC10 is relatively tricky for a front part of an AMC10, meaning that if you were to look at, say, the first 10 questions of this, these are not that easy. They are a bit more on the, like, what would usually be around questions like maybe 8 to 15 have become instead questions 1 to 10. I mean, not that they're super hard, but don't panic if you feel that how come the start is not so easy this year, because as we will see, the back end of this was pretty easy. Okay, but we're still at the front, so let's continue. Melanie changed some of these plus signs to minus signs and it was negative. What is the least number of plus signs that Melanie could have changed? Okay. When you add up 1 to 99, it is a pattern for the sum of odd numbers is a square number, right? 1 plus 3 is 4, plus 5 is 9, plus 7 is 16. So it's worth just knowing that this is the total. You want to change some minus signs to make it negative. That would mean that you start subtracting off the ones behind. And so on. Now, an easy way to think about it, however, is just that the positive portion, and then you're going to sort of have the negative portion, is what will happen when you just switch all the big ones to become minus here, minus there, and so on. And so in order for this to be negative, the positive part of it must be less than half of this. And the reason I go for that is that I know that the front part will just still be a square number. So I can calculate my square numbers. The nearby one is 35 and 36, meaning that you would have 35 numbers here giving you 1225, and then 15 numbers behind that will be having a negative sign in front of them. Answer is therefore 50. Okay, question 7. If you saw the AMC10A video, you saw that there were a lot of the least possible this and that. Here's another one, but this is pretty easy because it is integer side lengths and an area of 2024. We know that to have a small perimeter, given a fixed area, we want the sides to be quite close to each other. You should be aware when you take any year of the SMO, AMC, or any contest that we know the year's factorization, but also know some special properties. So 2025 this year is 45 squared. 2024, therefore, last year is 44 times 46. So we just use that. 44 and 46 will give you the smallest possible perimeter, which is 180. Okay, question 8. Right, arithmetic mean is just the usual average. So when you say the arithmetic progression, that's just a sequence with a common difference, and arithmetic mean is just the usual average. And so this is actually just a typical algebra question. However, it's just stated using this. So the average is 0 means sum is 0. Average is 10 means sum is 30. And what you want is this over 3. That is quite a standard operation that we get from the sum and the sum of squares. Basically, in order to make AB, AC, and BC appear, we just square A plus B plus C. This is what you get when you expand. And so you subtract off, you get this is negative 30. And so divide by 2 and divide by 3 again, you get negative 5. Okay, question 9. Whenever there's a geometry question, there may or may not be a diagram. If you are doing it on paper, then if there's a diagram, you can write on it. If you're doing it on a computer, then of course you will need to go and copy down the diagram on paper. What I would say is just that if they tell you that ABCD is a parallelogram, and there are no other length and angle information, then you can just draw it to be a rectangle. And that is fine. Whether we actually assume that or not, we should not assume it, but actually the method will be the same. Right? So, okay, this is what I have here. Now, because I've written it as a rectangle, it kind of makes things a bit clearer, but in reality, it's no difference if it were a parallelogram that we don't need to assume it's a rectangle. It just looks pretty clear that we have what I always call this hourglass pattern of similar triangles. Parallel lines always give you equal angles, and the equal angles give you similar triangles. BC to AE is 2:1, meaning that the scale is 2:1, and I can actually say that this is also 2:1. Okay, so I divide it here, and I can now say that BCE is half of the whole quadrilateral. That was divided in a ratio 2:1, meaning that BFC is 2/3 of half is 1/3. Meanwhile, your CFE is further half of that, is 1/6. And the CDE is clearly 1/4 of the whole thing. Okay, so 1/3, 1/6, and 1/4. Just multiply top and bottom by 12, and you get the ratio 5:4. Okay, question 10. Let n be the product of all the positive integer divisors of 42. What is the units digit of n? Well, this cannot be very hard because I could literally just list out all of the factors of 42 and just look at all the ones digits, right? So 2 times 3 is 6, 6 times 6, 36 ends in 6, 6 times 7 ends in 2, 2 times 4 ends in 8, times 1 again is still 8, and then times 2 here is 6. So you can just go like this. What I would say is that 42 is a weirdly small number for them to have chosen. In general, remember that you can actually pair up the factors. And so n in this case is just 42 to the power of 4. So you can use 2 to the power of 4 to get the last digit of 6 immediately. And in the event that they give you something like all the positive integer divisors of, I don't know, like 2024, then maybe you know what to do. Okay, so in the end, we have actually taken the roughly 15 minutes for the first 10 questions as well. This is what I said at the start, right? Slightly over 15 minutes at most. If you're aiming to finish the paper, that is around the pace that we're aiming for. But you can take up to 45 minutes for these 10 questions if you are aiming to qualify for the AIME. You do not need to find most of these shortcuts. Honestly, if you just do them in a very literal way, you could have done these just in a normal fashion within 45 minutes without needing to notice too many clever things. All right, so on we go. Question 11. This is a classic idea. What you want to know is that square roots are sort of like not accurately to call it primes, but I can sort of say square roots cannot be chopped up. Meaning that if let's say that you simplify the square root as much as you can, which I'll try to do here, 1183, it must be factorizable, otherwise there's no way I can split it up. So I will look for square factors that I can take out. 3 squared is not there. I suspect that it's divisible by 7. And it is, oh yeah, 7 times 169, so this is 13 square root 7. Now when I say square roots are not cannot be split up, it means that once you have taken out as much as you can and the inside cannot be further simplified, that's what we call a square-free value inside. No more square factors other than 1. Then the only way you can split it up is give a few of your square root 7s to the first one and a few to the second one. So it's sort of like a square root 7, b square root 7, where a plus b is 13. And so this would be what they actually look like. Now I want it to be small. What I know is that when I want it to be small, I don't want it to be, let's say, 1 and 12, right? That'll be very big. I want a and b to be quite close to each other. So I will let a be 6 and b be 7. Okay, and then you add them up, you get 595. So this is a known property when you have got square roots. Like let's say if you have got x and y, we call them unlike terms. Square root 2 and square root 3 are unlike terms. They're not going to combine together. And so I will not be able to actually combine these two into this unless they are all just copies of the same so-called base square root. Okay. Number 12. The moment I look at the diagram and I see a right angle on a straight line like this, this is a very popular similar triangle configuration. We saw the hourglass in the earlier question. Here, I immediately see the similar triangle, which is that this triangle is similar to this one. The reason is pretty simple. If you just look at these two angles, they are both equal to 90 minus this one. So therefore, these two triangles have the same set of angles. Okay, now that I will make use of, or I may not make use of, but it's too obvious when I look at the diagram and I have to say it immediately. Now let's see if there's anything else. Not really, it just tells me that WXM and WAZ have the same area. Okay. They have the same area. So what I would do is that I'll call this X, and then since this one has one side is halved, the other side must be doubled in order to have the same area. This is a rectangle. I can write this down. And so, okay, I realized that this is actually 2:1, right? 8 minus 2x and 4 minus x. This is twice of this. So therefore, this is 2:1 as well, meaning that this is 2. So actually, x is just 1. This length here is 2. This length here is 6. This length here is 3 and 1. Okay, now to get the area inside, I could use Pythagoras. But more simply, I'm just going to take the total area and minus the outer ones. So 4 times 8 minus half times 8 times 1, half times 4 times 2, and half times 6 times 3. plus 8 plus 18. So area of WMA is 50. Question 13. A group of 100 students from different countries meet at a math competition. Each student speaks the same number of languages, and for every pair of students A and B, A speaks some language that B does not speak, and B speaks some language that A does not speak. What is the least possible total number of languages spoken by all the students? Okay, this is actually surprisingly tricky for a question 13 in terms of logic. It's not very complicated, but it is a bit tricky nonetheless. Now, essentially, what this is saying is that if every student speaks the same number of languages, then as long as they don't speak exactly the same collection of languages, then there must be something that A has that B doesn't have and something that B has that A doesn't have in order to balance out. In other words, this entire thing just means that all the students, let's say, speak N languages, but a different combination of N languages. And so if they speak N languages, but a different combination of N languages, what does that mean? It means that if I have 100 languages, obviously if they each speak one language, that's 100, but they can speak N different languages. So, which means that if there are M languages in total, there are M choose N combinations that are possible, and I just need to make sure there's at least 100 available. I can look at these options and actually realize that, when we do choose, right, it increases quite fast. So I don't think I need to go that far. I will just take 9. And in fact, if you just take 9 choose 4, which towards the middle is bigger, right? The Pascal's triangle will remind you of that. This is already 126, meaning that 9 is enough. So if they each speak 4 languages, there are 126 possible combinations of 4 languages. You can certainly just have 100 of them, no problem. Right. Question 40. Now, when I look at this, I am pretty annoyed already because there are mean and median are both positive integers is a very lousy kind of information. So I can tell that this is the sort of careless mistake generating machine of a question. I'll say again, this paper is sort of one where they made the middle section, the front and the middle are not as easy as usual, perhaps. And then after that, right at the back, it turned out to be quite easy. So I personally would probably have just flipped ahead and looked at the rest of the paper at this point, right, which is about 25 minutes in. I would say that, let me look at what else is there, right? Because I don't feel like doing this right now. But so that this review is a little bit more coherent, I'm just going to continue in order. Okay. But we're going to be super careful whether we do this at the start, middle, or end. So it says the range is 7. The mean and the median are both positive integers. Okay, so I'm going to just make sure that I use each of these pieces of information at some point. Firstly, the range. Now, you have got 1 and 7, which are the current smallest and largest. X and Z have potential to be the smallest or largest. So my range is either going to be, if 1 is still the smallest, the biggest must be 8. And the biggest must then be z. This is case 1. Case 2 is that 7 is the largest and x is 0. That's allowed, right? It doesn't say that they must be all positive. And then the third is that x and z are both the smallest and largest, where z minus x equals to 7. So there are 3 cases here. Range of the list is 7. That is my 3 cases. Okay, now the next thing that I want to look at, I think, is just the mean. The mean can be calculated. My current sum of these, if you add them up, 1, 2, 3, 5, 6, 7, and then 4 of these 0.2s, this would give you a total of, I can't add, this is somehow confusing me weirdly. This is 24.8. So this must somehow be a multiple of 9. That's all I know. I'll worry about this later. I think at this point in time, median would depend on where the things are located. So I should split into the cases right now. Okay, so I'll start with the z equals to 8. So I've got 1, 2.2, 3.2, 5.2, 6.2, 7, and 8. And then x and y need to go in. Now, if I want to put x and y in, x or y has to be the median. So median means the 5th position. So what will happen is that either y will come here and x will be somewhere here, or x will be here and y will be somewhere there. Now we also then can use the mean to determine what's going on. Right, so for this case, this is 4 or 5. If this is 4 or 5, I will need 24.8 plus 8 plus 4, 36.8 plus x, or 37.8 plus x to be a multiple of 9. Now that is not going to work because there isn't a way that I can reach the next multiple of 9 while my x is smaller. So that does not seem to work very well. Okay, let me just do a quick check of something. Yeah, so that doesn't seem to work. Next case is that if x comes here, then x must be 6. Now if x is 6, then this will be 38.8 plus y, has to be a multiple of 9. in this case, you are going to get y can be 6.2. Okay, so I found what? Second case is when x equals to 0. So you can see why this is very annoying and you would normally want to skip this. But yeah, I'm just going through it to be systematic and I want to be as careful as I can. Okay. So 0, 1, 2.2, 3.2, 5.2, 6.2, 7, and 8. Now my z or my y has to be the median. It's either that, again, my z is here and y is somewhere there, or my y is here and my z is somewhere there. You can check it one more time. I guess if your z here is 3, then you will need 24.8 plus 3, 27.8 plus y to be a multiple of 7. That doesn't work. If I put y is here, y is 4 or 5 again. So y is 4 or 5. In this case, z can be 6.2 or z can be 7.2. Okay, so I seem to have found a couple of options there. And then the last one is if the z minus x equals to 7. Now, if z minus x equals to 7, I know that y has to be the median. So y has to be down here. Once again, you have got y equals to 4 or 5. Z minus x is supposed to be 7. And my 24.8 plus this is now 28.8 plus x plus z, or 29.8 plus x plus z. So it looks like for this case, because my z is more than 7, but my x is less than 1, I don't have a lot of room to move. This one would work if x plus z is 7.2. So y equals to 4, z equals to 7.1, and x equals to 0.1. Okay, so it does look like we have a total of 4 things that work after a pretty annoying check of all these cases. Now, we should do a quick confirmation though. So I have got this one here. So this, I've just checked that it works. And then I also have this 0, 5, 6.2 and 0, 4, 7.2. I realized that I wrote something wrong though, because I'm looking at my answer. And so I realized that this is not supposed to work, right? Because the 7 is supposed to be the range. If I have 0 and 7.2, then the range is not actually 7. So that is, in fact, supposed to be struck off. So there are actually only going to be 3 cases that work. This one, and the one we saw below. Now you understand why I want to skip this question. The AMC does not always give you questions that really make sense as a contest problem. This seems to have taken longer than like 10 of the previous questions. You probably should skip it, but I know in advance that the ones behind move pretty fast, so I was not too concerned about going back and forth and just checking all the cases one by one. Okay. So now let's speed up again. Question 15. 1 to 2024 on the whiteboard. Jerry chose 4 numbers, erased them, and replaced them by either their sum or their product. What does he want to do? He wants to make them all odd. So what's the maximum possible number of integers on the whiteboard at that time? Well, if you do this, each time you are basically erasing 3 numbers, right? Because you replace 4 of them by 1 number. So if you erase 3 at a time, technically speaking, I can already eliminate and say that the answer must be congruent to 2 mod 3, because 2024 is 2 mod 3, and that already eliminates most of the options, to be fair. Now, not only that, you can even just say that, well, I must erase all the even numbers at some point. There were 1, 0, 1, 2 even numbers that must be erased. So which means that you have at most 1, 0, 1, 2 left at the end. So obviously this is already correct. Okay, now if you are thinking of how do you actually do this, very easy. Just take the even numbers. Just keep on replacing 4 even numbers by 1 even number over and over and over again, until right at the end when you are left with 1 even number, then just combine them with 3 odd numbers. So that's how it works. Right? But you can exploit the answer options. So this is the sort of time where you can make up the loss in trying to bash through the previous question. Okay, question 16. A dartboard is this region, a target is this region. Okay. The AMC likes graph questions. When you have got absolute value of x plus absolute value of y is less than or equals to 8, essentially it means that in the first quadrant it is x plus y is less than or equals to 8, which is like this. And then after that you just reflect it, right? Because it is symmetric fully. So you just get this square, which is of course in a diamond you can call it, but it's a square. Now a target is this region where x squared plus y squared minus 25 squared is less than or equals to 49. Okay, this means that this is between minus 7 and 7. So between 18 and 32. Now that is just a pair of circles, right? X squared plus y squared is 32, will be a circle, which this is an abomination of a circle. It's better. And then you have got a slightly smaller one here. And your target is this ring. Technical name is annulus. You can call it a donut. This is T. So it lands at a random point in B. What's the probability that it lands in T? This is just straightforward. Use the areas and then you will get a ratio. Okay, so the area of this region, because the bigger circle is literally radius is square root 32, so just 32 pi and 18 pi. So this is just 14 pi, and this is just going to be 2 times 8 squared, which is 128. So this over this is 7 pi over 64, and so 7 plus 64 is 71. All right, oh no, another time waster question, but I think this is slightly less bad than the other one. How many of these are possible, basically? So a non-vertical line with the given slope can contain this number of lattice points. Okay, so 3 different cases. The first is zero slope. Zero slope means a horizontal line. For a horizontal line, if the y-coordinate is an integer, it will hit infinitely many. If the y-coordinate is not, then it will hit 0. So that's straightforward enough. Now the next is non-zero rational slope. Now rational slope basically means that you can think of it as if the slope is m over n, it just means that when you go from 1, you will definitely hit another one. And so once again, you will hit infinitely many. Unless you start off at something where, let's say you start at 0 pi, where one of them is already irrational. Then it's going to always be irrational. So this is going to be like this again. Now for the irrational slope one, it is pretty clear that the moment you have 2 rational points, then the slope is literally going to be just change in y over change in x. So that would be rational. So these are gone. It's also pretty easy to tell why an irrational slope, you could potentially never ever reach a rational point, let alone an integer point. So 0 is quite easy to understand. And 1 is also pretty easy to understand. Like if let's say that I just use y equals to pi x or something. Right? If y equals to pi x, it goes through 0, 0, but it will not go through anything else. Okay, so we're not going to write down proofs for everything. There's no time. And in the AMC, I think we're not desperate for like a perfect score, meaning that you would rather save the time to do more questions than to go and try to prove something, because there isn't really like a huge gain in expected value from doing that. So we can take it as 6. Okay, question 18. In a race among 5 snails, there is at most 1 tie. That tie can involve any number of snails. For example, the result of the race might be this. They're just giving an example. So it's just that there are ties. Okay. This is, again, surprisingly annoying for this middle section. I know that it is possible that there are no ties. That would give me the initial 5 factorial. Now it says there's at most 1 tie. So I'm just going to split up into that tie and everyone else. So suppose that there's an n-way tie. If there's an n-way tie, the first thing is I need to decide which n snails are in that tie. And then once I've put them together, then essentially it's just arranging them where these n snails, imagine they have been tied together. You have reduced it to 6 minus n groups, right? Because n has become 1. So you reduce it by n minus 1. Where your n can be 2, 3, 4, 5. Right? If you have a pair, then there's 4 groups left. If you have 3 of them, you're left with 3 groups left, so there's 6 minus n factorial. 5 choose n will include 5 choose 5. If they're all tied, there's only one way, so that makes sense. You cannot say 5 of us are all tied for third. That makes no sense, because if you're tied, you are first, if all are tied. Okay, so therefore, I just need to add this up. I've got the 120 there, and then for n equals to 1, 5 times another. Wait, not n equals to 1, sorry. No, that looked wrong, right? It cannot be so big, and there's no one-way tie. For n equals to 2, that is 10 times 4 factorial. N equals to 3 is 10 times 3 factorial. N equals to 4, 5 times 2 factorial, and then 1 times 4. So we add this all up, and it should be equal to 431. Another fairly tricky one, question 19. How many different remainders can result when the 100th power of an integer is divided by 125? It's a bit tricky because 100th power, you can't really find a pattern. It's not practical. So you would need to use Euler's theorem. Now, Euler's theorem tells you that a to the phi of n is congruent to 1 mod n when a and n are co-prime. Don't forget this condition. Very conveniently, phi of 125 is 4/5 of 125 is 100, meaning that a to the 100 will be just 1 mod 125. If a is not going to have a common factor 125, in other words, if a is not a multiple of 5, and of course if a is a multiple of 5, then the 100th power will definitely be divisible by 125 because 125 is 5 cubed. So there's only two possibilities, 0 or 1. I'm not going to explain Euler's theorem in this video. It is something that if you know what it does, then of course this is a simple application. If you don't know it, then you can go and search it out. But I would not consider it as like something that is commonly essential for the AMC10. Right? So whenever you're doing the AMCs, don't be surprised if something that you've never heard of before is suddenly used. It's not going to happen a lot, but it can happen a little bit. So even if you are, let's say, grade 10 / sec 4 / year 4 doing the AMC10, there's always still a small chance that something you've never seen before is used, let alone if you are slightly younger and trying the AMC. So don't be afraid to skip a question, just in case maybe there was no chance you would ever figure it out. Okay. Question 20. Another slightly tricky one. You have got, basically they say straight pipes, circular cylinders, but you can think of it as just circles, right? Just ignore the 3D aspect since it says a head-on view. The third circle is supposed to be down here. And they're asking you what is the radius. Okay. Now, I can sort of just take a skeleton of this in a way. right? And just ignore the circles after that. So all of this, when I say a skeleton, meaning that I know that this is 1, I know this is 1 and 1/4, I know this is 1/4, and so in fact by Pythagoras, if this is 3/4, then 3/4 and 5/4, this is 3/4, this would just be 1, right? So I don't want to involve the circles anymore because there isn't really any need. So this is my skeleton, and now I am putting a point somewhere down here. This is R, such that this distance is 1 plus R, and this distance here is R plus 1/4. And of course, this 1 is now, I'll refer to it as this whole thing here. There are various ways that you can finish off from here, but I think that I want to just continue on the Pythagoras route. Remember that I misspoke earlier. There is no trigonometry needed for the SMO Junior. Likewise, there is no trigonometry needed for the AMC10. It's just for the AMC12 that you require. And so I will just go with a Pythagoras-based approach. Just call this x and 1 minus x. There will be 2 equations, 2 unknowns, and then I trust I can solve it. So this would give me x squared is 4r. And this would give me r. Okay, so that just means that x squared equals to 4 times 1 minus x squared. X and 1 minus x are clearly positive, so I can square root it, and it would give me that x is 2/3. So you would then get, this is 4/9, this is 4r, so that means that your radius is 1/9. Except that that's not right, because this whole time I have drawn it like this, and you might not have realized it, but there's also a way that you can draw something like this on the outside. The good news here, if you can call it that, is that actually the equations still work. Because if all we have used is Pythagoras, I can just translate this into quadrum. And this would be the equations you get still. The only difference is that actually, I said earlier on you can just square root because x and 1 minus x are clearly positive. Well, 1 minus x may be negative if your center were actually outside this range. And so my 1/4 minus r, that may be negative, that's okay. Right? If you were to actually now just say that, oh, by the way, it can actually be minus x equals to this. You will just get x equals to 2 and r equals to 1. So there'll just be a second circle of the same size that turns out to work too. So I presented it in this way because, to be honest, I wanted you to see that it is very easy to make a careless mistake. And I don't like the term careless mistake. It's just an oversight. It's not because you were careless. But a way that we can remedy it is that we can just use coordinate geometry. So coordinate geometry would be that you just, instead of doing this, you just let the center of this, let's say, have fixed coordinates, like this thing here is 0, 1, this thing here is 0, 0, this thing here 1, 0, 1, 1/4. And then after that, you just solve for the equations and see what you get. Right? So let that point there be, let's say, xr, the center, and then just solve the equations and see what happens. So I'll leave it to you to verify that this is what happens. So the answer is 1 plus 1 over 9, which is 10 over 9. Now, normally I would be going a lot faster for the front part because I would say that we need about 30 minutes for the last 5. But that's not true here, as previously advertised. For those of you who are doing it on paper, do a quick flip through to see whether the questions at the back look scary at the start of the paper. If you're doing it on a computer, of course, you can just scroll. But maybe scrolling takes a bit longer, so you can sort of like leave that for when you are stuck on a question and just want to stare at some other things. Because you never know, and the ones behind may turn out to just be perfectly fine. Okay, so question here, 21. We're going to speed run through the last 5 questions in 15 minutes. It's perfectly doable. 16 people, 4 4-person committees. Each committee has 1 chairperson and 1 secretary. And of course, that means that 2 people who don't have any special designation. I'll start with step 1, which is just that I am going to pick 4 chairpersons. So 16 choose 4. Now, once I pick the 4 chairpersons, essentially the indistinguishable have become distinguishable. Right? It's sort of like we can have 4 different classes in the same classroom, but if they have different teachers, you will not call them the same class. So you have got 4 different chairpersons now. And so to pick the remainder, I'm just going to put 3 people here, 3 people here, 3 people here, 3 people here. So that's 12 choose 3, 9 choose 3, 6 choose 3. And then after that, you have to pick the secretaries for each group. And there's just 3 ways for each group to pick the secretary. Okay, my question is literally just asking how many trees can you find. So they don't want you to calculate all of it because that would take too long. So good on them for asking it this way. For the 16 choose 4, there's only 1 multiple of 3 on top. It got cancelled, so nothing. 12 choose 3. All of them actually have 3 numbers here. For the bottom, it is going to have 3 factorial, which is 6. So this one, gone. This one, gone. But this one still has a 3. So there's 1 more factor of 3 to add on to the list, and therefore it's 3 to the power of 5. In the factorization, r is 5. Counting questions are very short in terms of these kinds of like expressions, but it's very easy to get it wrong. If you got any other thing, it may turn out to be equal to this, right? Because 16 choose 4 times 12 choose 3 times 9 choose 3 times 6 choose 3 times 3 to the power of 4. If you did it in a different order, it may look different. But if you have a different answer, just take a while to check. Have I counted anything more than once? Have I accidentally assumed that order matters when it doesn't? Have I accidentally discounted order when it should matter? Okay, and here's another sequel to that. Three different pairs of shoes are placed in a row so that no left shoe is next to a right shoe from a different pair. In how many ways can these 6 shoes be lined up? Okay, I'm going to just name them first. L1, R1, L2, R2, L3, R3. Not L1, R5. L1, L2, L3, R1, R2, R3 for the different pairs of left and right. it basically means that my left and my right shoes, I usually would just put them in any order, but if I put the left shoe between two right shoes, one of them will be wrong. If I put the right shoe between two left shoes, that will be wrong. So I can do this, and if I don't want to have a right shoe between two left shoes, it means that if there are multiple blocks of left and right, the middle blocks must all have multiple shoes. So I can go with, let's say, left, left, right, 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 left. Can go with left, right, 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 left, left. And then I can go with left, right, right, left, left, right. And vice versa. So there will be a times 2 at the end, right? Because I can reverse this around. I just wrote those where the left shoe comes first. So these are the 4 situations, although the second and third are also symmetric. Okay. The first one, I just need to make sure that these two are the same. So there are 3 choices, and then 2 ways for the left, 2 ways for the rights at both ends. Case 2, there are 2 pairs. So if there's 2 pairs, I need to have 3 choices for the first one and 2 choices for the second one, and then the last 2 are fixed. The same thing happens for this. And for this one, basically when I pick the left shoe, the position, then the right shoe positions are fixed. So it's also 3 factorial. Okay, so there is 12, 6, 6, 6, and that sums up to 30 ways. And then vice versa means times 2, right? Vice versa means that not that I reverse it. Vice versa means change all the left to right and all the right to left. So 30 times 2, and my correct answer is going to be that there are 60 ways. Okay, 23. Now this is the Fibonacci sequence. What I would ask that we do is just find a pattern. Because there are so many patterns in the Fibonacci sequence that probably this is just testing us on one of them. So I write until 10 first. This is 1 over 1, 3 over 1, 8 over 2, and then 21 over 3, 55 over 5. Okay, so the first thing is that, oh, they are actually all integers. That's quite surprising. Maybe we didn't know that, but good. Okay, this is only until 20. So you've got 2 options from here. One is you continue writing down. Let's say you continue on. At some point you realize that, this is just the same Fibonacci pattern, right? Because 1 plus 3 is 4, 3 plus 4 is 7. So up to you whether you dare to take the risk. I'm going to tell you that it continues to work. You can do the division by writing them out in full, or you can just trust the pattern after you see this, especially if you're running short of time. Remember that you get 6 marks for a correct answer, 1.5 for blank. Basically means that if you think you have a better than 25% chance of being correct, you should guess. And I think you definitely are more than 25% certain the pattern continues. Okay, so you can continue adding on all of these. And if you continue adding all of these up, you are going to see that it is equal to 319. I'm not going to prove it. I'll leave you to show by induction, if you like, why this pattern actually works this way. Okay, 24. This is actually sort of an easier version of a question in the AMC10A. If you remember the one that was talking about divisible by 16, it's sort of easier actually, because if I were to just put this into over 8, I only am specifically needing to check 4 things. I just need to check this thing mod 8, and since 2024 is the multiple of 8, it's just minus 2, minus 1, 0, and 1 mod 8. So of course m equals to 0, this will clearly work. And if it is minus 2, you can see that each of them is going to be divisible by 8. So yes, for the case of minus 1 and the case of 1, you can actually just substitute in and you'll see that both of them also work. Doesn't take long. So all of them are going to be 0 mod 8. So we're done. It's all 4 of them. I have no idea why this is question 24. And lastly, I also have no idea why this is question 25. It sounds like it has the potential to be quite complicated. Let me shrink down these blocks because they are, well, blocking. It sounds intimidating, but it really isn't, because it just is a linear equation. It tells you the new block is 1 unit taller, 1 unit wider, and 1 unit deeper. They're not even telling you about volume, they're just literally comparing them and telling you that the height 2C is, the O1 is 3B, so it's 1 more than that. This thing 2B is 3A plus 1, and this is 7A equals to 3C plus 1. You don't really even need to do anything more clever. You just solve simultaneous equations normally. Right? So this is a bit bizarre, to be honest, why they put this at question 25. Yeah, so if you know what, I'll just solve the simultaneous equations. If you were to multiply this by 2 and this one by 3, so you get 4C equals to 9A plus 4. You multiply this by 3, you multiply this by 4, and you put this in, you get 28A equals to 27A plus 16. So I've done something wrong, haven't I? I have definitely done something wrong. Oh yeah, I have forgotten to multiply this by 2. Okay, so this should be 5, this should be 15, and this should be 19. So A is 19, B is 29, and C equals to 44. Pretty bizarre way to end. You can add this up and you get 92. But it's also a good instructive moment to say, please do not skip all the questions at the back. And somehow we actually have taken less than 75 minutes, even though we spent an age over some of the things in the middle, like especially this really, really annoying question, which there is no better way to do it. Please remember that if you are, let's say, time limited, meaning that you are doing more questions and you actually are afraid of running out of time, you should at least try to look at every question. If you're hoping to finish everything, you should still skip it first, because who knows, maybe that one question, by skipping it, you can do the other 24 questions. Certainly worth it for almost all of us. So do not assume that the questions are in order. And one final warning, because of the anti-cheating measures, you will see that the questions are jumbled. Sometimes the answer options can also be jumbled, meaning they may not be in ascending order. So like you may have the options are like 10, 5, 6, 8, 7. So just in case that happens, don't forget that, yeah, just look at it carefully. Don't just get confused by the fact that things are not in order. Okay, so Thanks for watching, and if you haven't already, you can also look at the AMC10A video. Remember that the AMC10A and the AMC10B are just two different contests. They are meant to be the same in difficulty. Just because they don't end up the same doesn't mean that that is deliberate. It's just coincidental because there are two different papers. Obviously, each of them will have their own features. So whether you're taking 10A, 10B, or both videos are still relevant. So do check that out. Okay, so thanks for watching, and the next one will also be the AMC 12B review in a little while from now.